Okay, so here is example 2 from the PowerPoint, and I'm going to do the first part. Part A is what we did in our class. It's just you evaluating something using a Riemann sum. And so they said use a sum take a sum of the area under curve of this, or evaluate the area under the curve of this expression. The net area is what it is, so it's the negative portion plus the positive portion, by taking the sample points to be the right endpoints, and they want us to start from A is 0 and B to 3, and this is on the x-axis, and they want six subintervals or rectangles. So this means we're going to take this sum from I is 1 to 6 of f of x sub I. Now if you look that I used x sub I didn't use x sub I star. That's because we're using the right endpoint, and so x sub I can be, that's what we can call it when we're using a right endpoint. So that will become important in part B when we use the formula for there. So this is the sum we're taking, and delta x. Delta x is b minus a divided by 6. b minus a divided by n is 3 minus 0 divided by 6. So each width is 1/2. So I sort of did a sketch of this curve. So this is the sketch of the curve right here. And so if we're taking the endpoints to be from the right and we're going 1/2, the first subinterval would be between 0 and 0.5. So the right endpoint would be at 0.5. So we go all the way down till it touches the curve and draw a rectangle over like that. And then we'd go another 0.5, which is 1 on the x-axis. And so we would draw till it hit the curve and draw over. 1.5, 2, 2.5 is up here, it's positive, and 3. And so this is the picture of what we did in our class. Okay, so what the summation looks like is going to be the width of this first rectangle, 1/2, times the height, f of 0.5. The width of the second rectangle, also 1/2, times the height, f of 1. The width, 1/2, height, f of 1.5, width 1/2, f of 2, width 1/2, f of 2.5, width 1/2, f of 3. And so that's what I wrote here. And then you can put that in your calculator and you can add all those numbers up. And this is the estimate of the area, the net area under the curve for this, this function. Now, I'm going to go through this next part in more detail because I think this is what you really had a question about, which is all this crazy summation stuff. So let me just start. Let me turn the page and we will start. Let me make sure you can see my notebook. Okay, good. So we are going to evaluate, we're going to express, no, what are we going to do? We're going to evaluate this. Evaluate the integral from 0 to 3 of x cubed minus 6x dx. This is what we're about to do. So what is the difference? Well, the difference is this summation is not 6 subintervals. It's an infinite number of subintervals. That's what that is. Since we will be using the right endpoint, instead of x sub I star, we're going to use x sub I. And so it is equal to a plus I delta x. That's what the x is equal to. So when we get to that, that will become a little bit important. So let's rewrite this in terms of using the definition. Remember, let me just show you the definition again. Here is the definition. Can you see it? Here's the definition of the integral from a to b, right? We're going to use this definition and we're going to define it in terms of the sum, only it's not 6 subintervals, it's going to be an infinite. We're going to add that little limit on there. Instead of using x sub I star, because we know it's the right endpoint, we're going to be using this. Because if we know it's the right endpoint, we can substitute that in for our x sub I. Okay, so that's what's happening. Just some substitutions. So, and we're going to say that this integral is equal to, so this is in general, the integral is equal to this, so this will, let me write it in general. This is the integral from a to b of f of x dx is equal to the limit as x, no, not x, sorry, as n goes to infinity of this infinite sum, I is 1 to n, of f of x sub I star, but I'm going to use f of x sub I. I'm removing the star because I know it's the right endpoint, and this is what I know x sub I is in my case. So we're going to start to see some substitutions going on. Delta x is b minus a over n. We know what b and a are because the upper and lower limits. So that's one substitution we're going to be making. So before I do substitution, let me take this, what the integral is defined to be, and let me replace f of x sub I with this right here. So this turns into the limit as n goes to infinity of the infinite sum from I is 1 to n of f of this is what I'm going to put in there. F of a plus I delta x times delta f of this times this. All right, now we're going to start to make some substitutions. If we know that delta x is b minus a over n, and we know that a is 0 and b is 3, this is equal to 3 minus 0 over n. Last time we put in 6 for n because there was only 6 rectangles. This time we don't know. So 3 over n is what delta x becomes. Okay, now we'll make that substitution in just a second. Let's look at a plus I delta x. A is what number? It is 0. So this is going to become, so a plus I delta x is going to be 0 plus I, and delta x we just figured out was 3 over n. So this is what it becomes. The limit as n goes to infinity of I is 1 to n of f of I times 3 over n, I times 3 over n times delta x, which is 3 over n. All right, now we're going to start applying a few of the summation rules. This summation involves expressions that have I in it. This 3n right here, this 3n does not have 3 over n does not have an I in it, so I am allowed to move it. Where can I move it? I can move it in front of this